Hi, how are you doing today? I'm going to solve the following problem. Through the use of analytic methods to find the intervals on which the function is increasing, decreasing, concave up, and concave down. After that, locate the local extrema and inflection points. The function given in the problem is y equals negative 2x cubed plus 5x squared minus 2. Our first step is going to be to take the first derivative of the given function. We're going to write y prime equals negative 6x squared plus 10x minus 0. Now you don't have to write the minus 0. I just did because next we're going to set this equal to 0 and solve for x. To do this, we're going to use a quadratic formula. So we're going to write y prime is going to equal 0, so 0 equals negative 6x squared plus 10x minus 0. We're going to solve this using the quadratic formula. So x equals negative b, my apologies, I forgot to write the x here, negative b plus or minus the radical of b squared minus 4ac, all this over 2a, and a would be the negative 6. So this is going to be x, we're solving for 0, so x of 0 equals. So we're going to rewrite this, 0 equals negative 10. The answer to this radical will just be 10, because 10 squared is 100, and this is 0. So 100 minus 0 is 100. The square root of 100 is 10. So plus or minus 10, all over 2 times negative 6, all over negative 12. So in x, where it's 0, x equals negative 10 plus 10 over negative 12, and x equals negative 10 minus 10 over negative 12. So the answer to this is going to be 0. So one point is x equals 0. And other point is going to be x equals negative 20 over negative 12, or simplified, x equals 5/3. So this is where the point is going to equal 0. So this is going to be our maximum and minimum values depending on where we're going to solve. So next we're going to set up a table using these 2 points that we have found. We're going to start at negative infinity and go to the first point we come across, which is 0. We're going to go negative infinity to 0. Then we're going to go 0 to our next point, which is 5/3. Then from 5/3 we're going to go to infinity. And we're going to set up our table. Now with the given values, we're going to use an x value in the domain, and we're going to plug in it into f prime of x. So in the range negative infinity to 0, the simplest thing to solve would be negative 1. In this range, the simplest thing to solve would be 1. In this range, the simplest thing to solve would be 2. So we're going to plug in negative 1, 1, and 2 into the y prime, which is right here. So we're doing y prime, or f prime of x, negative 6 times negative 1 squared plus 10 times negative 1 minus 0. Do the same thing with 1 and do the same thing with 2. When you solve this, you get a negative here, a positive number here, and a negative number there. You don't need to know the exact number, you just need to know whether it's positive or negative to figure out whether it's increasing or decreasing. So with the information we have now, we can determine whether or not and where it is increasing and decreasing. We now know that it is increasing on the intervals of 0 to 5/3, because this is where it is positive. We know that it is decreasing on the intervals of negative infinity to 0 and 5/3 to infinity. So this would be the answer to the first part. The given function y equals negative 2x cubed plus 5x squared minus 2 is increasing on the interval of 0 to 5/3 and decreasing on the interval of negative infinity to 0 and the interval of 5/3 to infinity. So this is our first answer. Now with this information we have now, we can determine where our local min and our local max are as well. Now the local min is when the value goes from a negative to a positive. So if evaluating this, it goes from a negative to a positive to a negative. So it goes from a negative to a positive would be at x equals 0. So this would be our local min. It's the local max when it goes from a positive to a negative. Again, examining data, negative to positive, positive to negative. It goes from a positive to negative at 5/3. So it's a local max at 5/3. Now to get the exact points, we're going to have our local min and our local max. Local min, we said, is at x equals 0, and we said our local max is at x equals 5/3. To get the y coordinate of that, we just plug in x of 0 into the original equation that's given. So you plug in x of 0 into this, you're going to get 0 plus 0 minus 2, so the point's going to be 0, negative 2. Now to find the local max, my apologies for forgetting to write max there, your local max, you do the same thing. You plug 5/3 into your given. You're going to come out with the answer of 71/27. Now you have your local max and your local min. Your local min at 0, negative 2, your local max at 0.5/3, and y value of 71/27. So now that you have where it's increasing, decreasing, and your local min and max, you have to move on to find out where it's concave up and down to solve the rest of the problem. So to solve where it's concave up and down, we have to take the second derivative of the given function. Luckily, we already have the first function. We already have the first derivative, so now we just take the derivative of the first derivative. So the derivative of this would be the second derivative. So right now, draw this so I can separate my work. Your second derivative, so y double prime, is going to equal negative 12x plus 10. Now again, to find out where it's concave up and down, we have to find where it's at its minimum and maximum values. So we're going to set it equal to 0. We're going to say 0 equals negative 12x plus 10. Now solving that, we're going to get x equals negative 10 divided by negative 12, or simplified equals 5/6. Hello, I apologize for the video being cut off. The video length became too long and it stopped filming. So I apologize. This will be part 2 of finishing the original problem discussed in part 1. Before I was cut off, we had just found the second derivative, set that equal to 0, and found that it was equal to 0 when x equals 5/6. We'd set up this table, of negative infinity to 5/6 and 5/6 to infinity. Now with this table set up, like in part 1 when we had y prime, we're going to take this, we're going to put in a value, an x value on each function, and then find f double prime of x. So let's say the x value here, it'd be simple to solve, is 0, and then simple to solve here is 1. So you plug 0 into there, so we get a positive number. Again, we don't need the exact number, we just need to know whether it's positive or negative. Plug 1 in, negative 12 plus 10 is a negative number. So now with this information, we know when it's positive and when it's negative. When it's positive, this indicates to us that it's concave up. So this function, y equals negative 2x cubed plus 5x squared minus 2, is going to be concave up on the interval. So concave up on the interval negative infinity to 5/6. Now, knowing that, when it's negative, that's when it's going to be concave down. So it's going to be concave down on the interval 5/6 to infinity. So this has solved another part of our problem. So this solved the point where it's concave up and concave down. It's concave up on interval negative infinity to 5/6 and concave down on interval 5/6 to infinity. Now we got one last part to solve, and that's the point of inflection. Now it says to solve for inflection points, but in this case there's only one spot where y double prime would equal 0. There's only one point of inflection, and that is 5/6. Now how do I know this? The point of inflection occurs when the second derivative shifts from a positive to a negative, or a negative to a positive. In this case, it shifts from a positive to a negative. And the point at which it shifts from a positive to a negative is 5/6. So our point of inflection, I'll represent by POI, is at x equals 5/6. Now if you want the y value too, which we will show you how to do, you plug the 5/6 into the y equals negative 2x cubed plus 5x squared minus 2. Now when you plug in 5/6 into that, you're going to get the y value of that is equal to 17/54. You could do this on a calculator, on a piece of paper. I'm running out of the room, so I just explained the math. I didn't show the math, but it's just simple algebra. So here we know our point of inflection occurs when at x equals 6 and y would be 17/54. For the math people, we'll write this that our point of inflection is at the point 5/6, 17/54. So this solves the last thing we were trying to solve and the last thing we were trying to figure out. So at this point, we have figured out everything asked for in the problem. We've used analytic methods. We use calculus by taking the first derivative, then the second derivative, setting it equal to 0, and using those points to find intervals on which it's positive and negative. We use that to find where it's increasing, decreasing, concave up, and concave down. And using our knowledge that when it goes from a positive to a negative, or a negative to a positive, that would indicate your local min or local max. And by plugging that value into the given original function, you figure out the y value, so we figured out that final point. We figured out our local min and our local max as well. Then using our knowledge that when a double derivative, the second derivative, shifts from a positive to a negative or negative to a positive, that indicates a point of inflection. In this case we have a point of inflection at 5/6. Now by plugging that in the original function, we solve the y value. So we have our point of inflection is 5/6, 17/54. So this sums up this session, and this answers all the questions. So it's increasing on 0 to 5/3, decreasing negative infinity to 0, and then 5/3 to infinity. The local min would occur at 0, negative 2. The local max would occur at 5/3, 71/27. The point of inflection would occur at 5/6, 17/54. In this graph, the graph of y equals negative 2x cubed plus 5x squared minus 2 will be concave up from negative infinity to 5/6, then concave down 5/6 to infinity. Thank you for watching. I hope you understand. If you have any questions, please comment on the video and I'll do what I can to answer. Enjoy the rest of your day, and thank you for watching.